Okay, so the review sheet from extra credit here, we're going to go through the answers real quick. So number one, we're finding the midpoint, which remember is the average. So the first thing we're going to do is we are going to use our formula. So either you can do it on the side or just add the x's and then add the y's and divide by 2. So x2 is -3 plus -1 over 2. And then we have 5 plus 7 over 2. So that's -4 over 2 and 12 over 2, which is -2, 6. And so the answer is just going to be B. For the second question, we're going to take our line and it's going to be parallel to this equation. So we have to solve for y to get the slope first. And then we're going to plug the point and that slope into the point slope form here. Now notice that none of these are in point slope form. So we're going to have to do a little solving here to get that equation. So step one, okay, we're going to we're going to do stuff. All right, let's just do it by hand. We're going to add that 8x over. Okay, so we add the 8x, divide by 4, and we're going to end up with y equals 2x plus 4, which means our slope is going to be 2. So once again, we're going to plug our point y minus -1, so that's going to be plus 1, is equal to 2 times x minus 2. All right, we're going to distribute through, because remember we're going to get it y equals x plus b form. We're going to get y plus 1 is equal to 2x minus 4. Remember, it's 2 times x and 2 times -2. And then subtract 1 to get our final answer, which is y equals 2x minus 5. And that's going to be choice 3 here. All right, let's take a look at number 3. All right, number 3 is choice 4. Let's take a look at that. So remember, we're starting with perpendicular to the given line. So the slope of that line is going to be 3 or 3 over 1. So the perpendicular slope, remember, is the opposite reciprocal or negative reciprocal, so it's -1/3. So we're going to plug -1/3, 6 in for y, -1/3 in for m, and then -9 in for x. So that's y minus 6 equals -1/3 x, and then plus 9. And then we're going to do the same thing. We're going to go ahead and distribute through. So we get y minus 6 equals -1/3 x minus 3, and then add that 6 to both sides to get our final answer, which is choice number 4. All right, number 4, we're finding the slope. So remember our slope formula, y2 minus y1. So remember second y coordinate minus the first y coordinate, okay, over x2 minus x1. So that's going to be, to start with, the answer is going to be 7/9. Remember, going to plug in, so -9 minus the -2 or plus 2, and then -6 minus 3. So that's just -7 over -9. And then you're going to remember we're going to change this, both of them are negative, so it leads to a positive 7/9, and that's our slope. For number 5, we want to know what's the dilation if there's a scale factor of 4. So remember, when lines are dilated, two things are going to happen. If they're dilated from the origin, the slope is going to stay the same, okay? And then the y-intercept is going to get multiplied by whatever the scale factor is. So what we need to do is find the equation of this line in y equals mx plus b form. So all we're going to need to do is subtract the 2x from both sides, and then we're going to take the y-intercept and multiply it by the scale factor, which is 4. So 1 times 4 is 4, so our answer is just y equals 2x plus 4, which is choice 2. Also, remember, if you look at your choices, it's either going to be the same slope or different. And then is the line going through the center? So if it passes through the origin, it stays the same. If it doesn't pass through, and like this one has a y-intercept of 1, then we know we have to choose the one that's not the same. So you can kind of use that to help you out here. All right, let's take a look at number 6. All right, number 6, we want the line that passes through point -a2 and is parallel to our given line. Remember, same slope, and we're plugging this point into our point slope form. So solve for y first. We're going to add 3x to both sides here. And then afterwards, we're going to divide by the 2 in front. So we should end up getting an equation of y equals 3 over 2x, or 1.5x, and then plus 6. All right. So the slope here, though, importantly, is just 3 over 2. Then we're going to plug our point and the slope into the equation. So y minus 2, because that is our y coordinate, equals 3 over 2 x minus negative 8, or y minus 2 is equal to 3 over 2 x plus 8. But the double negative becomes a positive. All right, number 7, we're doing the distance formula here. So remember, x2 minus x1 squared plus y2 minus y1 squared. So second point x coordinate is 2 minus negative 7, so 2 plus 7 squared. And 11 minus negative 7 is 11 plus 7 squared. So that's going to be 9 squared plus 18 squared. And that ends up being 81 and 324 for the square root of 405. Now, it doesn't say what to do, rounding or nearest simplest radical form, so you don't need to really take it any further. Now, the other option is you could have done the rise and the run again here, and then use Pythagorean Theorem. So we can see that this is plus 9 and then plus 18, and then you're going to do a squared plus b squared is equal to c squared. So a is going to be either 9 or 18. That goes in for a and b. And then once again, 9 squared plus 18 squared, we just talked about that, is 405. And then we just take the square root to get c by itself, and we get the same answer. So that was another option on how to get that length. Okay, we'll take a look at 8. Okay, so perpendicular bisector, remember we're doing the midpoint, the slope. We're going to use the midpoint and the perpendicular slope to state our equation. So the midpoint, x2, so 7 plus negative 1 for the x's. Oh, I can see we messed that up, didn't we? Let's go fix that. Have to make that change. So if you got the worksheet, this is changed. All right. So it's 7 plus negative 1 over 2. And then y2 is negative 5 plus 1 over 2. So this is going to be 6 over 2, which is 3. And then negative 4 over 2, which is negative 2. So there's our point. Our slope, we're going to go ahead and plug in. So it's going to be negative 5 y2 minus 1, which is negative 6, and 7 minus negative 1, or plus 1, which is 8. So that simplifies to negative 3 over 4. And then the perpendicular slope, remember, is the opposite reciprocal, so positive 4/3. As long as one of the numbers is negative, the whole fraction is negative. So this opposite reciprocal should be positive. And then we just plug in. So y minus negative 2, or y plus 2, is equal to 4/3, and then x minus 3, and there's our answer. So either minus a negative, or just change that to a plus, and do the plus positive here. Okay, number 9. Remember, the center is the point 0, 0, and we want to map A onto A prime. So remember, A, this is our pre-image here, okay? And this is our image here. So we're getting smaller, right? We're getting smaller. So our answer needs to be a fraction, okay? So it's 6. We're going a distance of 6 versus a distance of 2. So we're just going to do 6 over, or 2 over 6, I should say. And then 2 over 6 is just 1/3, or 6 times x, what number is going to give you 2, and you can solve that way, okay? So either it's going to be the scale factor for the image divided by the pre-image is one way to do it, okay? Or you can create a little equation itself. All right, number 10. So once again, we're going to take the line they gave us, figure out the equation, and since it's dilated from the origin, we're going to multiply the y-intercept by 5 over 2. So once again, we're going to solve for y. And you'll have a graph on the quiz for this, so you can just graph the line, multiply that distance, and then plot those points again. So add 10x, divide by 5 to get an answer of 2x plus 4. And then we're going to take 2x plus 4 and multiply the y-intercept times 5 over 2, which is 20 over 2, which is y equals 2x plus 10. So if you had a graph, okay, we had a graph, we'd want to graph y equals 2x plus 4. So 1, 2, 3, 4, okay? And then we're using a slope of 2. So essentially just, you're going to get something that looks like this. All right, 5 over 2 is 2.5. So this is a distance of 4. And then we just do 4, right, times 2.5, which is 10. And that's going to be where my new y-intercept is. and then the line is parallel, okay? And it's going to go through 10, and that's how you can get that, that distance there, okay? So 10 this way, 10 that way, redraw your line, and then you can state the equation. Same slope, y-intercept from the graph, and you're good to go. Okay, for number 11, we're not going to have to do area on the test coming up tomorrow. We are going to do distance. So remember, distance is just, or perimeter is the distance for all the sides. So you can count either the rise and the run for each point, or plug into the distance formula using the coordinates. So I'm going to put little AB, BC, and AC here so we know which is which, and then we just plug in. So it's y2, so 1 minus negative 3 is 4, 3 minus 1 is 2, and then we keep that in the square root. So 4 squared plus 2 squared is the square root of 20. It does say simplest radical form here, so that's going to be 2 square root of 5. Same thing for the next one. So x2 is, you can go from what to what here, but I plugged in y's again when it should be x's. Let's fix this. All right, the answer is not going to change, but so 2 minus 1 squared is going to be 1 squared. 4 minus negative 3 is plus negative 7 squared. The reason it's not going to change is because we're adding these amounts after we square them, and they square become positive. This is going to be the square root of 50, which is 5 times 5 times 2, so that's going to be 5 square root of 2. And then the last one, once again, we're going to go from negative 4. Oh, we did the y's again. I'll fix it. So 2 minus negative 3 squared, which is plus a positive, and then negative 4 minus 1, which is negative 5, gives us the square root of 5 squared plus negative 5 squared, which is 25 plus 25, so that's 50. And once again, this is 5 square root of 2. So if you guys remember, the perimeter, okay, is to add all the sides. And then all we're going to do is add 2 square root of 5 plus 5 square root of 2 plus 5 square root of 2. We can only add the radicals that have the same number on the end, so just the square root of 2's. And just like if there were x's, we just add the coefficients and keep the number the same. So this is going to stay 2 square root of 5 because that's the only square root of 5 we have. But 5 plus 5 is 10, and then that's times the square root of 2, and that's going to be our final answer in simplest radical form. And this is the perimeter. T-E-R. All right. For question 12, we want to kind of figure out what's going on now. The options are either going to be that the line is parallel or it's the original line. These are the two options. It can't be perpendicular, and if it passes through the origin, it's going to be the same line. So it's either going to be 2 or it's 4. We just want to check to see if this line that connects these 2 points crosses through the origin. So if you have a graph, you could plot those points and kind of get the idea of what's going on here. Or we could find the slope and use our point slope form to help us out. So if we do slope, it's y2, 6, minus y1 is 2, and then negative 2 minus x1, which is 2, and we're going to get 4 over negative 4, which is negative 1. And then when we plug into our point slope form, it's y minus, and we'll use this 2 here, y minus 2 is equal to negative 1 times x minus 2. So if we distribute the negative 1 through, y minus 2 is equal to negative x plus 2. And then when we add the 2 to both sides here to solve for y, we're going to get y equals negative x plus 4. So this line, the original line, passes through the point y equals negative x plus 4, has a y-intercept of 4. So it's not going to be the original line because it doesn't pass through the center at the origin. So the answer is going to be choice 2, okay? And in generally, it is going to be parallel to the original line. The only time it's the original line is when the center is on the line. All right, number 13, you won't need to do this on the test. Also, there's an issue where so what we're going to do essentially is just graph our lines and then shade them accordingly. So when you're doing your shading, okay, we can go over that real quick. You're going to look to see, number one, you're going to graph your lines like normal. So we start by, we start by plotting the y-intercept and using our slope. So y-intercept is 3, slope is -1, down 1, right 1, or up and left 1, and then we're going to shade. So since this is a less than or equal to sign for this line, we know that it's a solid line and it shades down. So we're going to shade this line down this way, okay? This black line, which is 8y is greater than 2x, we're just going to divide by 8 to get 1/4 x. And because there's no number attached, the y-intercept is 0. So we basically are going to go, this line is the wrong slope. This is a slope of 4. Let's fix this. Of 1/4, we're going to go up 1 and over 4. So up 1 over 4. And we're going to get this line. All right. All right, and we're going to shade down on this line, or up because it's greater than or equal to. So this line is going to be shading up. And then our last line here is going to be y equals -x plus 3. We just did that one. How about y equals x plus 5? So we put dots at 5 here. Okay, it's a slope of 1. So we're going up 1 over 1. And this line is a less than or equal to, so we are going to shade down from here. So we're just going to go ahead and graph our line. We can see where the lines cross here. And then when we shade down, and it's a solid line because it's an equal to there, we end up with this region right here. And this is our triangle. So this is where we would want to do the perimeter and area of this shape that's covered by all 3 shadings. So down from the blue line, up from the red line, and down from this line here, okay? And then, so basically we would do the same thing. Here's our intersection points. We're going to count, the rise and the run, or do the distance formula and add those together. But for now, we're just going over how to graph, and then we'll do more of this in the next unit here. Okay? Number 14, equation of the perpendicular bisector. So once again, find the midpoint. So we plug in our coordinates. So x2 plus x1, we're going to do our 6 plus 4 over 2, 3 plus -1 over 2, which is 10 over 2, and 2 over 2, so 5, 1. And then our slope, which is y2, 3 minus -1 over 6 minus 4. And that's going to be 4 over 2, which is 2. Remember, perpendicular means the slope is the opposite reciprocal. And we're going to plug the 0.51 and -1/2 in. So we're going to end up getting y minus 1 equals -1/2, and then x minus 5. Okay? For number 15, we want to see if these lines are parallel, perpendicular, or neither. Okay, remember, perpendicular is opposite reciprocal slope. Same line means that they're going to be the exact same equation. Parallel means they have the same slope, different y-intercepts, and anything else is going to be neither. So the first equation, we add the x to both sides. We divide by 3. We're going to get a slope of 1/3 and a y-intercept of +4. On the second equation, we're going to divide by 6. We get a slope of 1/3. So 2 over 6 is 1/3. And then -4, since it's +4 and -4 for the y-intercepts, we know they're parallel since their slopes are the same. Number 16, this one gets a little bit tricky. So let's take a look at this one first. Okay, so for 16, we are essentially doing 5/6 of the way. So point C is 5/6 of the way along AB. So if you consider cutting AB into 6 equal parts, point C is going to go at 5/6 of the way up the line. So what we really want to do in order to figure out where point B is, because we know the points A and C, is we want to figure out how much distance is covered by one of these squares. And then if we multiply it by 6, we'll know where B is. Okay? So what we need to do is use the rise over run here to help us out again. So to get from A to C, get from 12 to 9.5, all right, I'm going to have to subtract 2.5. And to get from 5 to -2.5, I subtract 7.5. So we have to figure out what am I adding to the x's and the y's to get from A to C. Remember, we want 1/5 of that number, so we know what each step along the way, 1/5 where these points go. Okay, so what we're going to do is take the rise over run and divide it by 5. So negative 2.5 over 5 is negative 0.5, and then negative 7.5 divided by 5 is 1.5. Okay, so all we have to do now is figure out to get from A, this point here, to get from A all the way down to C, is to take the coordinates of A, okay, which the change in x is negative 0.5. So if we're going to take the first coordinate of A, which is 12, and we're going to add on to it 6 times negative 0.5. That'll give us all the way from A to C. Remember, 5 movements was negative 2.5. So that's how we're essentially going to figure this out. So the work that was here a second ago was for 2, is we're going to add 6 times delta x plus and 6 times delta y to point A, which remember is 12, 5. Okay, so 6 times delta x, which is negative 0.5, is negative 3. So that is our new delta x. And then 6 times the change in y, which is negative 1.5, is negative 9. And then I'm just going to take the point 12. I'm going to add negative 3 to the x coordinate. And I'm going to take the y coordinate, which is 5. And I'm going to add negative 9 to it, or subtract 9. And we end up getting the point 9 and then negative 4. And this is our answer. All right. Whoops, that's supposed to be a highlighter. Okay, number 17. Now this is how we did this one in class. We're going to do this the same way. So step 1, we're going to use our ratio of 3 to 2 to determine the ratio, the fraction of the line, which is 3/5 for this one. And then we're going to multiply the rise, which is 10, and the run, which is 7, to get from x and y, times 3/5. So 7 times 3/5 is 21 over 5, which is 4.2. And 10 times 3/5 is 30 over 5, which is 6. And we're going to add that to the first point we started from, which is negative 3.2. And we end up with 1.2 and then 4. And that is our answer. And then number 18 was just to prove. Now this should have been a ratio of 1 to 1. So just be careful. The fraction is 1/2. In order to be the midpoint, you're 1/2 the way up the line. So if you figure out point A, which lies at the point 1, 2, and point B, which is at 7, 5, the midpoint, when you add 1 plus 7 and 5 plus 2 together, you get 4 and 3.5. So if you count the rise and you count the run, which is a run of 6 and a rise of 3, and you multiply times 1/2, and you add that to the first point, 6 times 1/2 is 3, 3 plus 1 is 4, and then 3 times 1/2 is 1.5, 2 times 1.5 is 3.5, and you can see that we get the midpoint back again. And that's it. That's your review sheet. So really, you won't have to worry about a question like this. These are the ones you're going to have to worry about when we get to the directed segments that we're going to have to study for. So just like we did on the worksheet from yesterday, if I give you 2 points, can you find the point that's a certain ratio or a certain fraction up the line? So just remember how to do number 17 here. Okay? Remember, when lines are parallel and perpendicular, their slopes are the same, or opposite reciprocals, okay? Or they have the same slope but different y-intercepts. The perpendicular bisector, you guys remember, we need to find the midpoint, the opposite reciprocal slope, and then we plug into our point slope form, okay? If we want to find the length of a segment, we do the distance, the slope, remember the slope formula, or rise over run. And if it's parallel to the line, we want to solve for y and keep that slope the same and plug the point into the point slope form. If it's perpendicular to the line, we want to take the opposite reciprocal and then kind of do the same thing here. All right, any other questions, let me know. Hope you guys have a great rest of your weekend. Remember, this worksheet is extra credit for tomorrow.